Okay, so on this one, we're going to take a look at functions and their inverses. So functions are inverses of each other if and only if both of the functions are following conditions are true. So note function f of and g are used for this condition. So with this one, we have the function f and g are inverses of each other if and only if both the following conditions are true. Stating the same darn thing. So condition number one, the composition, so this was composition notation. We just learned this in the last video. If you haven't watched function composition video, then go ahead and go back and watch that one if you're not quite sure what that means. This means that, if we first work out function g of x and then send that result through f of x, it should equal x. And for all x in the domain of g. And then same thing, we have to be able to send f of x, the result of f of x through g of x, and get x. So we have to be able to do this for both functions. If I find one function and send it through the other, I should get x. That means it's its inverse. It's kind of undoing what's being done. So with this one, for each pair of functions f and g below, find f of g of x and g of f of x. Then determine whether f and g are inverses of each other. Simplify your answers as much as possible. Assume that your expressions are defined for all x in the domain of the composition. You do not have to indicate the domain. So it's not asking us to tell them what the domain can't be or what the limitations are there. Because sometimes, I know in the last video when they were asking us to do compositions, actually it was the division video, they made us state the domain. So in this one, they're just saying, you don't have to indicate that part. So for this first part, A, we have f of x equals 2x minus 7, and g of x equals x plus 7 divided by 2. So we have our two functions. Remember, this is the second situation. We'll deal with that one separately. So we're going to do part A first. We're going to work out both situations, and then we'll do part B. So for the first one, we're going to do g of x. So, and this means, so f of g of x, this means that g of x will be substituted for x in f of x. So here's g of x, x plus 7 divided by 2. And this blue part here, this blue expression, is going to be substituted into f of x. So it was 2x minus 7, but now you can see x is that the whole g of x was placed in here. Okay, so we have 2 times the whole expression, x plus 7 divided by 2, minus 7. So now I'm going to go through, I'm going to work it out. 2 divided by 2 cancels, and I have x plus 7 minus 7. Well, 7 minus 7 cancels out, and I get x. So it equals x. Yay! Now we need to check the next one. We need to make sure they are both, in fact, inverses of each other. So we do know that one kind of direction works. We know that g of x will undo f of x, but we need to check to make sure that it goes the other way as well. So now we have g of f of x. So now this means that f of x, that 2x minus 7, is going to be substituted in for x for g of x. So here it is again, and I've made it blue. I've done this on purpose so that you can see it. Here's f of x, and I'm going to substitute it into the x plus 7 divided by 2. Now we're putting it into this piece. So just x becomes 2x minus 7. So now let's go ahead and simplify. So on top, I have negative 7 plus 7. Really, these parentheses don't mean anything. They were just showing us the grouping there. So negative 7 plus 7 cancels out. I have 2x over 2. Well, 2 divided by 2 also cancels out, just like it did up here. So you end up with just x. So they are, in fact, equal to x. So yay, they are inverses of each other. So you can fill in the little bubble and go f and g are inverses of each other. So let's go ahead and check the next one. So now we have f of x equals 3x, g of x equals 3x. So they both equal 3x. So in this one, part of the clue here, there's nothing that's going to really undo anything. That's actually, they're only going to increase each other. So we do actually like to see one with, multiplication, one with division, because that shows some kind of undoing. We also have an addition and a subtraction that also kind of shows the opposite or the inverse operations. So in this one, I kind of have a clue it's not going to undo itself. So first we're going to do f of g of x. So we're going to send g of x through f of x. So I have 3x substituted for x here, because remember they're both 3x. So 3 times 3, I get 9x. So that does not equal x. I already know they're not inverses of each other because they do not equal x. But I still need to check the second one because it wants me to fill this one in. Okay, so I already know I'm going to bubble in they're not inverses, but I get to check the second one anyway. So g of f of x, so we're going to send 3x through 3x again because they're both 3x. So we're going to get the exact same result. We're going to get 9x again. So does not equal x. So they were both 9x. They're both the same, but they're not x, so they are not inverses of each other. All right, so that is how you check for inverses. And the main idea in inverses of a function is basically the opposite. It undoes what happened in the first function. So I hope that helped, and I will see you in the second video, or the next video.